Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Musari Amin bin Azmi, and I will present for my part in the presentation on design of suspension overhead insulator for 132 kV. Our group member consists of Chung, Fakrul Syaidi, Muhammad Ikram, Muhammad Musairi, and Muhammad Syahmi. For the first part is introduction. Basically, we need to build an insulator with 432 kV depending on the standard specification. So we also need to draw a 2D and 3D model by using suitable software. We will run a simulation and analyze it, analyze the normal and electric field distribution on the design prototype, and also we will run a HVDC test to test the insulator with appropriate for a small scale project based on safety and regulation. So the problem statement, so we know that the insulator will attach the distribution line or transmission of electric power to the utility pole and transmission tower. So the insulator is supposed to support the suspended wires weight without letting the current flow through the tower down to the ground. So without the proper insulation, it will become more hazardous to people surrounding. So what we need to design is the design of the insulator need to be considered. The aspect included lifespan, the material effect, and the need to deal with environment impact. Objective. So the first objective is to design the insulator model that's suitable for 122 kV. Second is to simulate and analyze the normal voltage and electric field distribution of the insulator model by using FEA software. To conduct a lab high voltage test with following telco high voltage experiment manual. Last is to able to work in a group to solve complex high voltage engineering problem effectively in a given time. For the scopes, the first scope is design the 2D and 3D insulator using the AutoCAD and SketchUp software. Second is simulate this normal voltage and electric field distribution by using FEA software. For the project outcome, the first project outcome is understand the best design and the materials of insulator models by considering appropriate finding in the article. Second, manage to determine the suitable materials for the insulator models and learn how to use the AutoCAD and SketchUp. Learn the high voltage and electromagnetic field distribution of insulator by analyzing using FEA software. Analysis the company will present the findings analytically both in writing and oral format. So for technical summary, choose a concept. So we choose cap and pin ceramic porcelain insulator. So this is the 2D sketch of the cross section cap and pin insulator. So this is 12 string model in 2D sketch. So this is 3D sketch for the string insulator model. So the table of properties. So the properties, all the properties are stated. The voltage, the type, material, maximum length, clearance, conductor, fittings, insulator type, number of cap, pin, insulator length, weight of unit, and minimum failing load, all are stated. And the dimension for a unit cap pin insulator, the diameter is 280, spacing 178, through page distance minimum 340, ball coupling size 20, socket coupling size is 30. For the geometry model, so this is the geometry that we use for the simulation. So the boundary is open boundary. So the conductor have two types, is high voltage and ground. For high voltage is 122, ground is 0. So this is the material, consists of air, iron, porcelain, salt and water. And this is the permittivity of the materials. So that's all from my part. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Syahmi bin Kamal Zaman, and I will present on FEA simulation software part. First of all, the first part of the FEA simulation software. should be present by Fakhur Roshadi bin Cik Yassin, but due to his health problem, I will take over this part and present for all the FEA simulation software, starting from the technical summary to the result. Finite element analysis (FEA) is a computerized method for predicting how a product reacts to real-world forces, vibration, heat, fluid flow, and other physical effects. FEA shows whether a product will break, wear out, or work the way it was designed. Finite element analysis helps predict the behavior of product affected by many physical effects, including mechanical stress, mechanical vibration, fatigue, motion, and heat transfer. It contains a CAD-like interface for the structure and the description of material properties and boundary conditions of the question to be solved. Basically, FEA simulation software is the second process after designing the process. It is to check whether the product can withstand physical effects such as mechanical stress and maybe overvoltage due to lightning and switching. This is an important process to know the capability of an insulator before being processed. Next, the process flow simulation. The first step is we design the geometrical model. The model that we use for the simulation consists of two, which is a single insulator and a 12 unit of string insulator. Okay, this is a single unit of insulator, and this is the 12 unit string of insulator. Basically, combination of a 12 single unit insulator being read together into a string. Okay, next, we set the material used. There are three main material used for the insulator, which is iron, porcelain, and the fitting, which is steel. Same goes for the 12 string of insulator. Next, we set the test condition. The condition that we will check for the simulation is the normal condition, contamination condition, salt condition, and water condition. Then we assign the domain properties according to the test condition. Okay, domain properties according to the test condition. By using the design, we will include the such as this contamination part into the design and change the permittivity of contamination to 80. Same goes for the 12 unit of the string. Then if the result obtained is satisfied, we will analyze the result after doing the all the condition. But if the simulation showed the result shown is not satisfied, we will get back to the step, maybe because of the use of wrong permittivity or the design of the wrong design for the simulation. After that, the technical summary of methodology. There are 5 stages that must be done, which the first stage is the sketch model. The model, like I said before, the model that we use is one single unit insulator and 12 unit of string insulator. Then we set the material and boundary condition. Then we set the load. The load that we use is 132 kV. And then the meshing of the design, then post-processing. Next, I will discuss on the FEA simulation result. Okay, this is the initial design in the FEA simulation. This is the single unit insulator, and this is the 12 unit of string insulator. Next, the permittivity that we use for the simulation. Before that, permittivity or dielectric constant is defined as the ability of a substance to store electrical energy in an electric field. The permittivity that we use for the contamination case is 80, the salt case is 15, and the water case is 80.3. Okay, this is the single unit insulator result. This is for the normal condition, while this is for the contamination condition. As we can see, the contamination condition, the water distribution is higher than the normal condition distribution. Okay, we show the simulation on FEMM software. Okay, this is the design for a single unit insulator, which the normal condition we use air with permittivity 1. Then we analyze the design, and okay, this is the for the single unit insulator. The blue color indicate voltage is lower than the purple color indicate the voltage is higher. Then we find the voltage graph. Okay, for the normal condition, this is the voltage graph for normal condition. It looks smooth, and then we also find the magnitude of electrical field intensity for the normal condition. Okay, this is the graph of length vs magnitude of field intensity for an insulator with normal condition. Then we also make the simulation for contamination condition. By changing the insulator, we add the contamination on the insulator, and we change the surrounding to contamination condition. The value of the contamination permittivity is 80. Then we match the design, analyze. Okay, this is the contamination condition of an insulator. We also, by doing the same step like last time, we find the voltage graph. Okay, this is the voltage graph. It is a little bit different for the normal condition, and this is the magnitude of field intensity. It is very different from the normal condition. This is the graph of length vs magnitude of field intensity for an contamination condition. Due to the contamination, the field intensity is being disturbed, so the intensity along the insulator is not same with the normal condition. Okay, we move on. Okay, this is the result for normal result. We will try to compare it with other condition. This is the contamination result. As we can see, the result is very different for the normal result. Okay, this is the salt result. The permittivity that we use for the salt result is 15. Is also different from the normal result. And this is the water result. The permittivity that we use is 80.3. This is almost the same as the contamination result because the permittivity is almost the same. After that, okay, we are doing for the 12 unit string insulator. Okay, this is the normal condition of a 12 unit string insulator with the combination of 12 unit of single insulator combining into a string side, with the air as the surrounding, indicating that the condition is normal. Then we do the meshing process, analyzing process. Okay, this is the water distribution for a 12 unit string insulator. There we need to measure the clearance distance between those insulator, and take the voltage graph. This is the voltage graph for a 12 unit single insulator, 12 unit of string insulator. The graph is between length vs the volt. Then we also measure the magnitude of field intensity for a normal condition. Okay, this is the magnitude of field intensity for normal condition for a normal condition. Okay. Then we also test for a case for this part. For the 12 unit part, I choose water case. It also the same as the single unit. We add a little bit of water. This sphere, the half sphere is indicating water with permittivity of 80.3. We just add the water on the insulator, then doing the meshing process, analyzing process. Okay, it's okay. This is for water case. Then we also doing the same step, measure the clearance distance between the insulator, take the voltage graph. Okay, this is the voltage graph between length vs volt graph for the water condition. As we can see, it's almost the same as the normal, but it's a little bit, it's not smooth as the normal condition due to the disturbance from the water. Then we will also measure the magnitude of field intensity. Okay, this is the magnitude of field intensity for the water. It's not the same as the normal condition. Then we will move on. This is the normal result for the 12 unit string insulator. This is the contamination result. This is very different from the normal result due to the disturbance of the contamination. Okay, this is the salt result. It's almost the same like normal, but for the voltage, but it's not as smooth. Okay, this is the water result for the 12 unit single insulator. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikram bin Mahad. So today I will present about the analysis of FEA simulation result and data observation. So as you can see, for the left one is the unit of insulator and the right one is the 12 unit insulator. So this is the result for the electrical field that have been flow into the insulator. So for the first one, the electrical field is flow at the 2 point, which is the first one, this and this one. The electrical field strong when the radial become close each other, like this part and this part. So this is the strong electrical field, and this one. It at the center of the insulator. This is where the weak electrical field that have been produced. For the second insulator, the electrical field that have strong have built at this part. As you it can explain by the electrical field are concentrated at the connection between the metal and the insulating material. That can be explained by a manufacturing fault at the time of installation. the further away in the radial direction of the insulator point is, the less the electric field become. So at this point, the less electric field become. When the radial direction of the insulator point is become closer to each other, the electric field becomes stronger. So this is these two insulator, which is the clean condition. For the next is the analysis of the graph for both insulator. So this one for the unit of insulator, and this one for the 12 unit insulator. As you can see, the point of the electrical field start at high and decrease slightly, slowly decrease and increase back, which is this part. The electrical field are strong at this part, and it flow to the low weak electrical field, and it increase at this part again. For the 12 unit insulator, it start with a low electric field, and suddenly it rise at one point, which is it start with this point with a low electric field and rise at this point, which is the higher electrical field. So for the next part, I will explain about the electric field in contaminated insulator. In contaminated insulator, the insulator will be affected by the contaminated, which is from the environment, air, salt, which affect the insulator performance, will be weaken the electrical field condition. So the most common being such as insulation degradation, transmission line, and the substation insulator exposed to contaminated in the air gradually get coated with salt and air. The contaminated form arise mainly from the industrial emission, so these affect the insulator performance. As you can see, the electrical field become weak for these two insulator. This is the analysis of the graph for the contaminated insulator. As you can see, the result is really not good for the electrical field. It starts from the low point and increase at some point, decrease back and increase and decrease back. For the 12 unit insulator, the electrical field start at low point. So each of the results show the weak electric field strength in each of the insulator. This is because effect from the environment, and it reduces the performance of the insulator. Moreover, the insulator effect at more affected at the uh, region where they have a ocean, because there are more salt in the environment. So, in conclusion, for uh, better of insulator, it needs the better material in the insulator so it can long lasting. That's all for me. Thank you.
Selamat sejahtera Dr. Lee. I'm Chong, and now I'm going to present the high voltage testing part. The safety regulation is very important, and we need to know this safety regulation before we conduct the high voltage testing. First, for the fundamental rule, before entering a high voltage room setup, all the members should first guarantee that all the conductor or the equipment which can accept the high potential in the contact zone are ordered and all the fundamental leads are interfaced. This is to ensure that the voltage or the current that live in the equipment is discharged. Next, the facings. The metal faces is used to is used as a safeguard or the high voltage setup. Next, the third one is the safety lock. The safety switching may likewise work the non-voltage relay of the power electrical breaker, which on opening the door, the interrupt on all the main lead to the setup. Next, this is the very important part, which is the earthing. The fixing the earthing lead onto the part to be earthed must be done with the end of the insulating rod. The earthing rod is used to discharge all the equipment which contain the high voltage. Okay, next, this as we can see, this figure is the setup for the HVDC test. And we use the TECO high voltage equipment in high voltage laboratory UTHM. As we can see, this equipment is the transformer, which is the step out transformer to step out the HVAC voltage. And then there is the two diodes, which is used as a rectifier to convert the HVAC voltage to the HVDC voltage, and as a function to smooth the voltage. And here is the measuring resistance is used to measure the load, which is the suspension type insulator. And this is the earthing rod, which is used to discharge all the components which contain the high voltage, to discharge the voltage and the current which left inside the equipment. And the grounding switch is used to bring the voltage to the earth. Next, for this diagram shows the simplified version for the test setup for the HVDC by using the TECO equipment. And we can see from this figure, the suspension string type insulator is suspended beside the measuring resistance to measure the voltage, breakdown voltage for the suspension string type insulator. Okay. The conclusion for the HV testing proposal. There are several conclusions can be made from the HV testing proposal. First one is the suspension insulator is tested under high voltage direct current, which is HVDC, for the dry and wet test in the high voltage laboratory UTHM. For a heavy pollution level or contaminated, it is suggested to take the longer creeped distance as compared with the clear area. From this project, we also learned that the safety is very important in engineering field. Before the experiment is performed, a careful planning and the guidelines should be done. Every precaution need to be known before we do the testing or during the testing, because the high voltage can cause the death to us if we did not do the proper safety features seriously. Next, the recommendation for future work. There are several recommendations for the improvement that can be done. The first one, ensure that the surface of the insulator is clear without any substance or fluid. It is important to ensure there is no water trapped at the insulator, because as the water is contained in the insulator, they will affect the breakdown voltage. Lastly, is the creeped distance is important in insulator. It is also known as the linkage distance for insulator. There is the significant to increase the creeped distance give the effect to the insulator. And for the pollution level, it is suggested to longer the creeped distance. Now I will continue with the risk assessment form. it is important to fill in the risk assessment form before we conduct the HV high voltage testing in UTHN laboratory. We can see here the risk assessment form which contain the hazard and possible consequence, and how we need to minimize or eliminate the risk, and the severity of the occurrence. And we can see that for the hazard which contain the electric shock from the high voltage, and how we could minimize this risk, which is the equipment is interlocked, so the supply are isolated when door to case is open. And the severity of occur is 5, rating 5, and the risk rating is also 5. Next, this also contain the electric shock from the high voltage spark or fire or slip, which contain the water and trip, chemical content, and wrong wire and circuit connection. And then this column show how we to minimize or eliminate this risk. For example, for the wrong wire and circuit connection, we need to make sure the wire and the circuit connection are done according to the TECO procedure. Or rapidly check the wire and circuit connection that has been constructed for the testing. Then the record for the chemical used within the experiment. The sodium chloride is used in the testing, and it has a function is used to make up the solution of correct conductivity for the testing. The method of disposal, the chemical evaporate during the test. Very small value is used in the test. And then this one is a hazard checklist, as we mentioned just now, which contain the electric shock from the high voltage, low voltage, tripping hazard, slipping hazard, and then some more the chemical content. That's all for the risk assessment form. Now I will continue with the cost form, which is the chemical handling assessment form. For the cost assessment form, which is the handling chemical, we can see that the sodium chloride is used in this HVDC testing, and the hazardous properties such as the sodium chloride may cause the eye irritations, and how we could eliminate this risk. We need to check and or remove any contact lenses, or if we contact the eyes, we need to flush with the water for 15 minutes. And then if slightly hazardous in case of skin contact, we need to wash and the clothing before reuse. For the quantity, the very small value is used in each testing, which is 0.1% plus minus 0.002%. And then most of the chemical products evaporate during the testing, and product to be handled carefully by wearing the appropriate lab coat or glove and mask. That's all for the cost assessment form. That's all for me. Thank you.